Hey there, Calculus 1. Welcome back to Recitation for Math 141, Summer 2020. As always, it's your boy Bailey here. We have episode 10 today. We've hit double digits, so happy birthday to us. And today we are going to be doing some inverse magic tricks. Return a card, any card. Get it? Because we're like undoing a magic trick. So the magician would normally be like, pick a card. But now we're like, return a card because we're undoing it. I'm sorry, I thought about a title for a long time, and then I decided I should probably get going, so I just went with it. We are going to be doing problems from section 3.8, which looks at the derivative of inverse functions and logarithms. And then in particular, in section 3.9, we look at inverse trigonometric functions. So today is all about inverses. Heck, even logarithms, even those guys are inverses, really. They're inverses for e to the x. So lots of inverses today. Just as a quick reminder, inverses are functions basically that undo other functions. So the logarithm, for example, undoes the function e to the x. So we got a good number of problems lined up today. There are some tough ones in this bunch. We're going to be doing lots of chain rule again, so that is always exciting. And the first one which we are going to do is the second problem on the homework. So let f of x equal 5x cubed minus 9x squared minus 5. And we're told x is greater than or equal to 1.5. That's not going to be super important for us. However, it is important that it says that from a technical standpoint. But it's not going to be super relevant for us. Find the value of df inverse dx at the point we are given is x equals 751. Oh my goodness. But thankfully they tell us that that is just f of 6. And that will come in handy later, knowing that this is f of 6. Okay, so there's a nice theorem in the book which describes how to find, it's really a formula, I should say, it's a better word for it, which helps us find the inverse of a function, the derivative of the inverse of a function. So we have that f inverse. So if I look at f inverse and I take the derivative, so f inverse prime, of some point b, well, the way that we can compute that is we can do 1 over the derivative of f, and then into that derivative, plug in f inverse of that point b. So we'll go through, of course, this specific example in just a minute, but the idea here is that we can just flip the derivative and then plug in, not the point itself. Notice that we're not plugging in b into the derivative. We're plugging in the inverse of b. In other words, so this is going to be the x value that satisfies f of x equals b. Okay, so notice that on the left-hand side we have f inverse prime of b, and on the right-hand side we're plugging in something slightly different. So we'll see how that comes in here as well. So theoretically, we could go through if we wanted to, and I'll write this down, but generally I think this is going to be more work. But I'll go ahead and note that we could do this theoretically, and sometimes this is plenty easy. We could also just compute f inverse and then take the derivative as we normally would. Just compute f inverse. Right, that's something we've done before. That was a chapter 1 thing, I think. And then take the derivative of f inverse directly. But again, I think a lot of times, usually, this formula, which we just wrote out, is going to be easier for us to use. And that's certainly going to be the case here. Take derivative of f inverse directly. Okay. So let's look at our specific function here. Let me copy it again down here, just so we don't forget it. So f of x equals 5x cubed minus 9x squared minus 5. And our point was x equals 751, which was f of 6. Okay, so looking at our formula, we can see that we're going to need to compute f prime, because that goes in the denominator on the right. So let's start with that. Let's start by computing f prime of x. So f prime of x, okay, and you see here, taking this derivative is not so bad. This is just a nice straightforward power rule. So 5x cubed, I'm going to bring that 3 down, and that will be 15x squared, lowering that exponent by 1. Now bring the 2 down for the 9, and I get minus 18 x to the first power now. And then the 5, well, its derivative is 0 because it's just a constant. So we've got f prime of x. I hope that you can see from that computation at least. Again, we could go through and find an inverse of this, but oh man, that would be a lot of work, and a lot of work that I would not want to do. Whereas taking this derivative is fairly straightforward. So this is definitely going to be helpful here. Okay, so we want f inverse prime of b, and our point is 751. Okay, so then we want f inverse prime of 751. Well, that's going to be 1 over f prime of f inverse of 751. Now, let's remind ourselves, f inverse of 751, this is just saying what x, oh boy, what, not w, at, what x satisfies f of x equals 751. And that's why I told you it's very nice that they told us that 751 is just f of 6. So this is going to be, our derivative then is going to be 1 over f prime of, well, f inverse of 751 is 6. So f prime of 6. And to find f prime of 6, we just plug it into our fancy formula, which we just found. So we just found that f prime of x equals 15x squared minus 18x. So 1 over 15 times 6 squared minus 18 times 6. I'll leave it to you to compute that. Let me see if I can do it real quick. That's going to be 18 times 6 is 108. 15 times 36, well, 5 times 36 is 180, so just do that times 3, 540. So I think this is 1 over 432, but I could be wrong on that. I did that very quickly in my head, so I'll put a question mark here, because I'm not certain of that. Pretty sure that's right. This is certainly correct, so I'll go ahead and circle this. And again, you can simplify that on your own. But again, so kind of the point of this problem is we get to practice using this very nice formula. Okay, this is a very nice formula to know. It looks a little bit tricky. The notation that the book uses is kind of ugly. This way, the way they write it here is fairly nice, but then they write it another way just below that in the same box, and that way is very scary. So I definitely prefer this way of writing it. Again, the tricky part is kind of in this denominator, but as long as you remember that f inverse of b, that's just asking what x value spits out f of x equals b. As long as you keep that in mind, you should be in great shape. And you can take inverse derivatives all day long. So that's what we're actually going to do, is we're going to keep on taking some inverse derivatives. The next problem I have selected is problem 5. I'm going to do a slightly modified version of the one that is on my computer. I think that the one on my computer is, how do I say this? It's kind of a little bit too easy. And when I say that, it's not too easy of a problem. But I think that if I change it a little bit, I can make it more instructive. So I'm just going to throw an extra constant or two in there to make it more interesting. So find the derivative of y with respect to t in our function is y equals, okay, so how did I write it? I wrote it as 4t. My computer didn't have the 4 out front, and my computer also didn't have 3t on the inside there, they just had t. But I think this will make it more educational. Okay, so our function is y equals 4t ln 3t squared. So let's take a quick second to review the derivative of the natural log, because that looks like it's going to come into play here. So as a reminder, the derivative of ln of x is just 1 over x. Now you do have to be careful because you'll oftentimes have to use chain rule, and we are certainly going to have to do that here. But this is the general form. This is the general short version, right? If I just have ln of x, now if I had ln of 2x, for example, then I'd have to multiply by the derivative of the inside. We'll see that in just a second. For now, I see that my function, so I have y equals 4t times ln of 3t squared. I see that I've got two functions being multiplied together here, this 4t and ln of 3t squared. So that means I'm going to have to use product rule. Okay, so in using product rule, you can label them however you want. Let me call it f of t, seeing as t is our variable. I'm going to call f of t 4t, and I'm going to call g of t ln of 3t squared. Okay, so now we want to take the derivative, so dt of f times g of t. You'll recall that is just f prime of t times g of t plus f of t times g prime of t. Okay, hopefully this is getting fairly familiar to you now. We have our product rule formula. So let's go ahead and let's compute our two derivatives. So f prime of t, well, that's not so bad because f of t is just 4t. So that's just a very nice straightforward power rule, and that is just a 4. Now g of t looks a bit trickier. So g of t equals ln of 3t squared. And actually, the way that I want to do this is I want to use chain rule not once, but twice. So hear me out for a second. Oh boy, how do I want to label these functions? Okay, so let's do it in blue, I suppose. Okay, so for g of t, I'm going to do the following. So I'm going to name three functions here. Let w of t be 3t. Okay. Then I'm going to let v of t be ln of t. Actually, let me write it this way. Let me write v of w equals ln of w. That will make it easier. And then I'm going to let u be a function of v, and that's going to be v squared. So now notice then that if I look at u composed with v composed with w of t, well, that's just u of v of w of t. So many letters, I know. Right? Because so w of t, so let's go ahead and write this out so we can see it. So u of v of w of t is 3t. So this is u of v of 3t. Okay, well, v of 3t, if I plug 3t into v, then I get ln of 3t. So that's equals u of ln of 3t. And then u says take whatever's on the inside and square it. And so this becomes ln of 3t squared. And indeed, that is equal to g of t. Let me prove it to you. There's g of t. See, I'm not lying. Okay, so we need to take, we need u composed with v composed with w prime of t. Okay, so this is going to be u prime of v of w of t. Now we need to multiply that by the derivative of the inside. So this is times v prime of w of t. And then I need to do that times the derivative of w. Okay, so this is just the chain rule. So there's, really we're applying the chain rule twice. Chain rule, and then we apply it again over here. So first we apply it to u of v of w, and then we apply it to v of w of t. Okay. So now this looks all scary, but we've broken it down into digestible pieces. So let's go ahead and compute u prime, v prime, and w prime. Let me also say that if you see this more quickly and you're able to go through and do this kind of without explicitly writing everything out, by all means, please feel free to do that. I'm going slowly so that I hope everybody can see where everything is coming from. But I'll admit, whenever I do these problems now, like on my own, I generally don't think through all of these steps explicitly, because the more you practice, the more comfortable you get. The more you practice, the more comfortable you get, and you kind of see how things work without writing everything down explicitly. But whatever works for you. Okay, so notice, so whenever we took u prime, that just gave us 2v because of the power rule. Whenever we take the derivative of v, that's where we're going to use this new derivative of the natural log. The derivative of the natural log is just 1 over whatever's on the inside. So it's just going to be 1 over w in this case. Now, if we had a more complicated function in there, then we would have to chain. And actually, that's kind of what we're implicitly doing here. So then w prime of t, let's see, w prime of t, w is 3t. So that's nice. W prime is just 3. Okay, let's go through and do this thing. So let's go ahead and substitute our values in. So u prime of v is 2 times v. So that's going to be 2 times. Now here we want to plug in v of w of t. Well, v of w of t we found to be ln of 3t. So 2 times ln of 3t. Okay, we can kind of see that here. This v of w of t, first it turned into v of 3t, and then it turned into ln of 3t. Okay, so 2 times ln of 3t. Okay, now I need to multiply that by v prime of w of t. Well, v prime says do 1 over whatever is on the inside. So let me go ahead actually. Yeah. So this guy corresponds to these two parts. And then this part here is going to correspond to this part here. So that says put 1 over, in this case, w of t. And w of t was 3t. So it says do 1 over 3t. And then w prime of t, that's this final part that we have to multiply by, and that is just 3. Okay, so this started out looking like it was going to be a hot mess, but it's actually not going to end up so terrible because we can simplify this. I'm dividing by 3 here, multiplying by 3 here, so those cancel. And I have 2 ln of 3t on top over just t, it looks like, because we canceled the 3. Whew, oh boy. All of that, and we still have to plug everything into the product rule. But we've got our f prime. So f prime of t equals 4. Wow, that one was difficult. So f prime of t equals 4. So let me go ahead and emphasize that this is g prime of t. So we've got g prime of t down here. And now we can plug in. So it says multiply f prime of t by g of t. That's how we get started. So that's going to be 4. So 4, let me go to a different color now. So we're going to have 4 times, let me write y prime. So this is y prime equals 4 times, and then we need g of t. G of t was ln of 3t squared. Ln 3t squared. So here I have, this is f prime of t, this is g of t, and then plus, so now I'm going to need f of t, right? Yep, and f of t is 4t. And then I'm going to need to multiply that by g prime, which is our beautiful contraption up here, 2 ln 3t over t. So we've got, this is f of t, and this is g prime of t over here. And this will simplify a little bit. And so that's equal to 4 ln 3t squared. Let me see, I've got a t here dividing by a t here, so those cancel. And looks like I've got plus 8, because I've got 4 times 2, ln of 3t. Oh boy. So that was a fun one, but it looks like we have figured it out. Okay, again, as you get more comfortable, maybe you're already at that point, maybe you'll get there soon, or maybe you won't get there, and that's okay as well. But as you get more comfortable, you are, of course, welcome to skip some of this work, right? Whatever you're comfortable with. Of course, you have to show something, but I hope that breaking it down like this is helpful for some people. Okay, so you can break it down to these product rule and chain rule. You can break things down into those rules. And then, as long as you're careful, we can break the really complicated looking stuff into relatively simple stuff. For example, the derivatives we took at the end here, these u prime, v prime, w prime up here, these are very straightforward derivatives. So these weren't bad at all. And then we just plug them into an uglier formula. Alrighty. So without further ado, enough blabbering, more differentiating, please. Let's do problem 6. And problem 6 says to find the derivative of y with respect to x, y with respect. I feel like you should always do things with respect to x. Why would you not be being respectful to x? That's kind of mean. I don't know. Perhaps that's just me. That's, of course, a joke. Sometimes you're not taking derivatives with respect to x. That was a terrible joke, as I tried to kill time while I wrote. Okay, so find the derivative of y with respect to x. And our function is y equals ln 10x over 10x. So this looks to me like a quotient rule problem, because I've got one function over another function. So this is quotient rule. Let's go ahead and remind ourselves. This says that the derivative with respect to t of f of t over g of t is, okay, so this is, I think, a trickier formula to remember. This is going to be f prime of t times g of t minus, now I'm going to leave f alone and take the derivative of g, and then we divide by g of t squared. Okay, so in this case, I guess we have functions of x, but it looks like ln of 10x is going to be f of x, and 10x is playing the role of g of x. So let's see, the ingredients which we need to compute are going to be f prime and g prime. So let's get on that. So f prime of x. Okay, so f of x, we have ln of 10x. So this one, well, let me break this down real quick. So again, kind of like what we did last time, let's let, let's let v of x rather, v of x be 10x, and u of v be ln of x, or ln of v. Okay, so we're going to do chain rule again. We're doing chain rule again because I see that I have this 10x within the bigger function of ln. So what I'm doing down here is I'm breaking it down in terms of its composite function. So it's remember this thing. So yeah, what I'm trying to say is that then, so f of x is just, let me see, I do v first. So u compose with v of x, and to confirm that, well, let's see, u of v of x. Okay, well, if I plug in, so v of x is 10x, and u says take whatever's on the inside and natural log that baby. So yeah, this is f of x. Okay, so that means then that f prime of x is going to be u prime of v of x times v prime of x. Okay, so this right here, this is chain rule, which we are applying. So let's go ahead and compute u prime and v prime. U prime of v, see, u is ln of v, so that's just 1 over v. And v of x, so it's v prime of x, is just 10 because v of x is 10x. So plugging this into our formula, we see that f prime of x, so u prime of v of x, so u prime says do 1 over whatever's on the inside, so in this case v of x. V of x is 10x, so this is 1 over 10x. And then multiply that by v prime of x. Well, we just found that v prime of x is 10. And so this is just 1 over x. Okay, so that worked out nicely. The 10s are canceling here. All right, so that gives us f prime of x. We're going to need that later for quotient rule, so star there, help us find it later. We also need to find g prime of x. And we see that g of x is 10x. Oh, so that's not so bad, thank goodness. So g prime of x is just 10, right? Because g of x is 10x. Okay, thank goodness. I was worried we're gonna have to do another circus act in order to find that derivative. I mean, I'm disappointed that we didn't get to do chain rule again. Shoot, darn. Okay, so now we're gonna go back to quotient rule and plug all of our data in. Data is a plural word, so keep that in mind, folks. It's the plural of the word datum. It drives me crazy when people say the data, use data singularly. It doesn't actually drive me crazy. F prime of t times g of t in the numerator. So f prime of t, well, I guess in this case, f prime of x. So that's going to be 1 over x. So y prime equals 1 over x times g of x, so times 10x. And then minus, so if I look back at my formula, okay, so we did f prime of x times g of x. Now we do minus f of x times g prime of x. And f of x was ln of 10x. So minus ln of 10x times g prime, which is just 10. Okay, so let me label this for you. So this 1 over x, this guy is just, wait a minute. Oh yeah, that was f prime. F prime of x. 10x, this is just g of x. ln of 10x is f of x. And the 10 here, this is just g prime of x. Then we're going to divide that all by g prime of x squared, or by g of x squared, excuse me. So that's going to be over 10x quantity squared. So 10x, this is just g of x. Okay, so let's reduce this a little bit. I've got 1 over x times 10x, so x's cancel, and this just becomes a 10. And then I still have minus 10 ln of 10x, nothing I can really do there for now. Over, if I multiply 10x squared out, I just get 100x squared. Oh, I see 10s everywhere. All right, I've got 10, 10, 10. So this is going to be 1 minus just one copy of ln 10x. And now instead of dividing by 100x squared, I'm going to divide by 10x squared. And I think that gives us a solution. A very nice and cute solution, in my opinion. Okay. So once again, we use the chain rule. Here we also threw in some quotient rule. Good stuff. So I hope that you're seeing how these different rules, which we learn separately, of course, but they all come together in order to help us find derivatives. They're good friends, they're not competitive, they get along very well and work as a great team. Problems 8 and 9 will be fairly short, but I want to do them, or I think just 8 actually is the one that's going to be particularly short. No, 9 will also be fairly short, but I want to emphasize with them what these inverse trig functions represent. This is something that I don't think was ever explained to me very well, or if it was, I just zoned out and missed it. But in any case, it's a very tricky idea, so I want to highlight it here. Okay, use a reference triangle to find the given angle. The angle which we seek is cosine inverse, otherwise known as arc cosine, of 1/2. So the key here, and I'll write this out in words. So cos inverse of x, this, what it spits out is what angle in the interval 0 to pi, I'll call it what angle theta in this interval. Why is that ruler there? Oh my goodness, no, I don't want you. I'm not trying to measure anything. How do I get rid of you? Nope. I'm not sure why. Can I get ruler, go away? Is this thing, no, it's not like a voice thing. Oh, here we go. Haha, I'm figuring this out. What angle theta in this interval satisfies cosine of theta equals x. So that's all that this is asking. Now this is important because we must emphasize, so this is not saying this is, rather than this, let me write, maybe I should have written the bad one in blue, or in red, that's okay. Not CS, cos inverse of x is not 1 over cosine. Right, we are used to this -1 exponent, meaning flip it, meaning doing 1 over it. And usually that's right. For example, if I had like, I'm not going to write it because I think that would just be more confusing. But if I had like the inverse of x squared, it would be 1 over x squared. Or like what I mean to say, not x squared, that's a bad example because that's not exactly what that means. If I were to write like 2 to the -1st, what I mean there is 1 over 2. However, with functions, as I hope you have seen to this point in this course, that inverse is different. Okay? So this is a very important distinction. 1 over cosine, this right here, well, this is a secant. And this is secant. And that is a totally different thing. Okay. So what we are asking here really, and this is why it's actually going to come out to be a fairly short problem. So cos inverse, or arc cosine, however you want to say it, arc cosine of 1/2. I like saying arc cosine usually instead, because to me, that helps me remember we're looking for a particular arc. We're not just flipping it. But whatever you prefer. So cos inverse is asking where in the interval 0 to pi is cosine of theta equal to 1/2. And because we are all experts on our unit circle now, right, we know that this is pi over 3. If you are not an expert on your unit circle, keep working on that, as you've probably seen to this point in the course. If not, unfortunately, it will come back to get you. Okay? So again, the point I wanted to highlight here, arc cosine or cos inverse, this is asking where in this particular interval, basically what it comes down to is where is cosine equal to this angle? That's what it's asking. Where is cosine equal to this angle? It is not saying flip it. So keep that in mind as we progress forward. The next problem, do I want to do 9? I should also mention, I'm going to skip 9 because 9 is basically the same. I will just make a note here that what I said about cos above, about arc cosine, I said about cos inverse applies to all of the trig functions right? So like sine inverse, tangent. I accidentally hit the power button and my thing shut down for a second and it stopped recording. I don't remember what I was saying. But the intervals change. Okay, so here for cosine inverse, oh boy, now it's all sideways and I don't know why. So cos inverse x, the interval was oh my goodness. Okay, I'm portrait mode. In fact, I have it on orientation lock, so I don't know why it's doing that. 0. I am so sorry. Cosine inverse lives in the interval 0 to pi. Sine inverse lives in the, oh good, the first screen recording was saved to photos. Sine inverse lives in the interval, I'm blanking, negative pi over 2 to positive pi over 2. Yes, that's what I meant to say. Right? The point of us restricting these domains like this, or the point of us restricting the range like this, is that otherwise there are multiple points on the unit circle, for example, where sine of something is equal to 1/2. So we just restrict the domain here so that we have a well-defined function. That's the basic idea. You don't need to know the details, but that's basically why we have these restrictions. Arctangent lives in the same interval as sine. And then for the arcs of all of these, for the secant, cosecant, and cotangent, it's the same interval. Okay, so same for secant inverse for cosine. Same for cosecant inverse. Or excuse me, no, that's not true. Yes, it is true. Yes. It is. I'm losing my mind. Same for cosecant inverse, and this is the same for, yes, that is the same. I was confusing myself because I was confusing like cosecant and arcsine. I was confusing myself on the thing I just told you not to get confused on. So that's why I warned you about it, because this stuff is tricky. So problem 9, which I was going to do but decided against, you're going to do the exact same thing as an 8, except you might have to make some slight adjustments for the interval. It's the same thing. Okay, next up is problem 12. Problem 12. Oh, okay, so now we're going to find an inverse trig derivative. So 12 says go away. I don't need you right now. Thank you. Find the derivative of y equals cosine inverse, or arc cosine, of 3x to the 5th with respect to x. With respect to x. Okay, so these inverse trig function derivatives, you probably should memorize them. I wish, if depending on how comfortable you feel, you may feel comfortable deriving them on the spot. However, they're kind of tricky. So it probably would be worth memorizing rather than trying to derive every time that you need it, unfortunately. But whatever you feel comfortable with, one way or another, this derivative we know, or we will know, is 1 over square root of 1 minus x squared. Okay. So in this case, we can see that we again are going to have to use the chain rule, because inside of this arc cosine, I've got this other function, 3x to the 5th. No, I want you like this. There we go. Look at that. So, what I'm going to do, just like before, is I'm going to let v equal v of x equal 3x to the 5th, and let u of v be equal to cosine inverse of v. Okay, so again, we've broken this function down into a composition of two other functions, right? So then cosine inverse of 3x to the 5th is the composition of u composed with v of x. So this means that y prime is going to be, we're going to have to take the derivative of u, so it's going to be u prime of v of x times v prime of x. So u prime, that's the one that we just wrote out, so u prime of v, well, we just wrote that the derivative of arc cosine is 1 over root 1 minus x squared. So u prime of v is 1 over root 1 minus v squared. And then v prime of x, well, v of x is 3x to the 5th, so by power rule that looks like it's going to be 15x to the 4th. We're going to bring that 5 down and lower the exponent by 1. And so the derivative which we end up with is y prime equals, okay, u prime says do 1 over square root of 1 minus, and then for v, we're plugging in v of x, which is 3x to the 5th. So minus 3x to the 5th squared. And then we're going to multiply that by v prime of x, which is 15x to the 4th. Let me write that another way real quickly. 15x to the 4th over root 1 minus, and if I square this guy, I'll get 9x to the 10th. And that gives us our derivative. Okay? So this is very similar to the problems which we've been doing. The main difference being now we're using one of these inverse trig derivatives. But really, these derivatives kind of have ugly formulas, I'll admit, but you use them just the same way as you would use other formulas. Okay. 2 more problems, and these 2 I am so excited to do. So these guys are doozies, let me tell you. So much math, I am so hyped. Let's get started. They are problem 14. That's the first one. Find the derivative of, okay, so y equals ln of tan inverse of 9x cubed. Is that right? Do I get 3? Does it get 3 parentheses there or 2? I think just 2. Just 2 parentheses there. Oh, with respect to x. With respect to x. Yes! Oh my gosh, this one looks so legit. Too legit to quit. Here we go, ladies and gentlemen. So again, I see, holy smokes, it looks like I've got 3 functions going on here. I've got this ln, then within that, I've got arctangent, and within that, I've got 9x cubed. Holy cow. So again, we're going to have to do, I think we're going to have 3 functions to do chain rule with. So let's go ahead and get going. I'm going to start by letting w of x be 9x cubed. Then I'm going to call the next one v of w, and that's going to be my arctangent. And then I'm going to pick up my natural log, and that is going to be, let's call that one u of v, and that is ln of v. So this one is complicated enough. Let's go through and double check that we got that right. So let's see. So y equals, so I think that it should be equal to u composed with v composed with w of x. So let's see what that comes out to whenever we work it out. So that should be equals u of v of w of x. Now I get 3 parentheses. W of x is 9x cubed, so that's u of v of 9x cubed. See, this is a great thing about math, is we can go back and we can make sure that our setup is right before we do a bunch of work with it, only to find that it's wrong. So that's going to be u of v of 9x cubed. Well, v of 9x cubed, that's going to be tan inverse of 9x cubed. And then u says take whatever's on the inside and natural log that thing. And so this just becomes ln of tan inverse of 9x cubed. And indeed, that is exactly what y is equal to, ln of tan inverse of 9x cubed. Hence, by chain rule, we see that y prime is going to be u prime of v of w of x times v prime of w of x, and then times, is that right? Did I do the right parentheses? 1, 2, 3. I'm missing a parenthesis there. And then times w prime of x. So this should look familiar to what we've done earlier today. So let's go through and calculate our derivatives. So u prime of v, let's see, u of v is ln of v. So remember the derivative of the natural log just says do 1 over the inside. So 1 over v. V prime of w, let's see, well, v of w is arctangent. Ooh, okay. So let's remind ourselves what that derivative is. So the derivative of arctangent of x, this is one that comes up quite a bit in Calc 2 actually, is 1 over 1 plus x squared. Yeah, this is a popular one in Calculus 2, so one that you definitely would like to be familiar with. Okay, so we're just going to copy that down here. So then the derivative of v with respect to w is 1 over 1 plus w squared. And finally, we have w prime of x. Well, let's see, w of x is 9x cubed. So that's just 27x squared by the power rule. Oh boy, okay, so let's go ahead and I'm going to copy down my functions as well because we're going to forget about them otherwise. And we're going to have to keep scrolling up. So u of v was ln of v. V of w was tan inverse of w. And w of x was 9x cubed. In a few weeks, we're going to learn how you can undo derivatives. That's basically what I just did real quick, was I undid all of these derivatives. Right? I started with the derivative and went back to the original function. That's called anti-differentiation, very fitting name. And I'm excited to get started with that in a little bit. But for now, let us go ahead and plug stuff into our formula that we wrote out. So y prime equals, okay, so u prime says do 1 over the inside. Well, the inside of that is v of w of x. Okay, so that is, let me see. So that's 1 over, now v of w of x, v, so that's going to be 1 over tan inverse. And then for w, we're going to plug in 9x cubed. So 1 over tan inverse 9x cubed times v prime of w of x. So v prime is 1 over 1 plus w squared. So 1 over 1 plus, now w of x is 9x cubed. So that's going to be 9x cubed squared times w prime. And w prime of x was just 27x squared. And so we can rewrite this a little bit, I suppose, but really it's not going to get much nicer than that. 27x squared over tan inverse 9x cubed times 1 plus, and then I can square that to get 81x to the 6th. 81x to the 6th. And that's our derivative. This is a fantastic problem because it uses so many ideas. It's using, let's see, we used chain rule, we used the derivative of arctangent, we used the derivative of the natural log, the power rule. We really ran the gamut here. You got to love it. So really good stuff here. That's a great problem. I would not, and I truly just guessing, like I'm not saying this with any like wink wink, I'm truly just saying I feel like that would be a great exam problem. Again, it uses so many ideas. So if I was the instructor, something like that would totally be on the exam. Okay, finally, let's wrap up with the final problem on the homework. I looked at this one and I was like, oh baby, let's go. Find the derivative of y with respect 2x. And our function, brace yourself for pure awesomeness, y equals ln. Notice the big parenthesis, x squared plus 8 to the 5th. And you're like, oh, that's not so bad. Boom, over. And you're like, okay, well, I can let, boom, radical 9 minus x. Oh, baby, let us go. Let's do it. Again, it looks real bad, but we're going to break it down and do it little by little. So here we go. Sorry, give me just a second. Okay. Okay, so here we go. Sorry, I was reading my recitation request that I had gotten, but we are good. So, okay. What we're going to do, so I'm going to let, I want to find a nice way to break this down. And I'm going to start with the following. So I'm going to start by let g of x, let's just focus on the inside. So let g of x equal x squared plus 8 to the 5th over root 9 minus x. And then f of g, so f of g is going to be ln of g. Okay. So first we're going to go ahead and use chain rule. When I say first, you'll see what I mean in just a second, because we're going to have to do a bit more work here. So chain rule says that the derivative, so y prime is going to be f prime of g of x. Oh, I should mention, so y is equal to f composed with g of x, which I will not take the time to go through and show that here, but you should if you are not comfortable with that. Okay, so y prime equals f prime of g of x times g prime of x. So we've got, we can go ahead and do f prime of g of x, right? So f of g is ln of g. So that means that f prime of g is just 1 over g. So this first part isn't so bad. So this is equals, we're just going to flip this fraction g of x. So it's going to be root 9 minus x over x squared plus 8 all to the 5th power, right? Now this g prime, that is going to be the pain here, because I can't just look at g of x and instantly know what its derivative is this time. So let's go and compute that. Let's copy it down here and get started on that. So g of x, just to copy it down so we don't have to keep scrolling up, that's going to be x squared plus 8 to the 5th power over square root of 9 minus x. Now for this, we're going to have to do quotient rule. Okay, so quotient rule tells us that let's call our numerator, let's call my numerator a of x and my denominator b of x. So then quotient rule tells me that g prime of x is going to be a prime of x times b of x minus a of x, b prime of x, all over b of x squared. And that part actually isn't going to be so bad because we've got a radical down there already. So that radical will just cancel. But finding a prime of x and b prime of x, that isn't going to be an easy task either. So a prime of x, let's see, well, a prime of x, okay, I'm going to skip a little bit of the chain rule, writing everything out explicitly here, but let's talk through it. So I have this function x squared plus 8 to the 5th. So to take its derivative, what I do is I apply the power rule first. So I bring the 5 down front. Okay, so I bring the 5 down front, and then I have x squared plus 8 all to the 4th power. And then I multiply by the derivative of the inside, the derivative of x squared plus 8, which is 2x. Okay, so that is my a prime of x. And this is whenever I talk about getting more comfortable with chain rule, this is what I mean. That's how I usually do it. I usually just walk through it that way. And so maybe if that, I don't know what I'm trying to say. If you were able to follow along with that, maybe you can continue doing things that way. If you need to stop and break it down into the functions like we did before, totally fine. Stick with whatever is working for you. Okay, so now b prime of x. Well, I noticed that b of x I can rewrite as 9 minus x to the 1/2 power. The benefit of that is that I can again apply the power rule and chain rule to give me b prime is 1/2 times this 9 minus x function to the negative 1/2, lower the exponent. This is just the power rule that I did, except instead of just like a variable, I did it to 9 minus x. And now I have to multiply by the derivative of the inside of 9 minus x, and that's just times negative 1 in this case. Okay, so I think that we have all of the necessary ingredients. So let's plug them into our g prime formula. I'm going to give myself plenty of room here. G prime of x equals, okay. Well, that denominator is going to be very nice. Let's do that first. So b of x is root 9 minus x. So b of x squared is just 9 minus x. Because when you square root, you get the thing under the radical. Okay, now let's tackle this first part. A prime, so a prime is, let's combine the 5 and 2, so I get 10x times x squared plus 8 to the 4th. So this, let me use blue. This right here is a prime. And then multiply that by b of x. Okay, so b of x is going to be negative, it's going to be negative 1 over 2 root 9 minus x. All that I did there was a little fanciness with the exponents and the negative exponent and the fractions. Okay, so that is b of x. B of x. Now we're going to subtract a of x. So a of x we said was x squared plus 8 to the 5th minus x squared plus 8 to the 5th. Okay, and then, oh, excuse me, this is not b of x. This is, I wrote b prime of x. Excuse me, this is b of x. So b of x is actually just root 9 minus x. Root 9 minus x. Okay, that makes it a little bit nicer probably. B of x. Okay, so now minus a of x, so that is x squared plus 8 to the 5th. And now I'm going to multiply by b prime of x, so that's going to be negative 1 over 2 root 9 minus x. Again, just a little bit of fanciness with the exponents there. If you want to pause this and take a second to do that. But the negative 1/2 in the exponent just means put a square root in the denominator. And yeah. Okay, so let's see if we can simplify this a bit. So let me see, that's going to be 10x, x squared plus 8 to the 4th, root 9 minus x. Okay, and then I've got minus a negative, so at the very least I can add these things. So plus x squared plus 8 all to the 5th over 2 root 9 minus x. And all of that over 9 minus x, and I think that's probably as good as we're going to get here. So that's g prime of x. And remember, the reason that we needed g prime of x was so that we could plug it in up here in for g prime of x in the chain rule. So I guess I'll go ahead and write it all down here. So y prime, okay, so f prime of x was, or was it? Root 9 minus x. We might actually get some cancellation, we'll see. Root 9 minus x over x squared plus 8 to the 5th. And then times everything that we see here. So times 10x, x squared plus 8 to the 4th. Root 9 minus x. Plus x squared plus 8 to the 5th, all over 2 root 9 minus x. And yeah, actually, I do think some stuff is going to cancel here. All of this over 9 minus x. Okay, so let me multiply this through. I know it looks like super ugly here, but we can actually make this much better, I think. So, whenever I distribute on top the root 9 minus x, well, with this first part, I'm going to be left with 10x. Let me make that more clear. 10x times x squared plus 8 to the 4th. And then I have root 9 minus x times root 9 minus x. So that's just going to give me 9 minus x without the radical. Now I'm going to distribute the root 9 minus x to the other part, and the great thing about that is that I will get rid of the root 9 minus x in the denominator, because they'll cancel, and I'll just have x squared plus 8 to the 5th, all over 2. And in my denominator, I now have x squared plus 8 to the 5th times 9 minus x. Next, let me, well, okay, so I see that I've got powers of x squared plus 8 all over the place. I have, all of my terms have at least x squared plus 8 to the 4th. So I'm going to divide everything by x squared plus 8 to the 4th. So now that exponent in the denominator is gone, and so is that one in that numerator. And I can split this up further into two separate fractions and write 10x times 9 minus x over x squared plus 8, 9 minus x, plus x squared plus 8 over 2, all over x squared plus 8, 9 minus x. Now, this left-hand fraction, 9 minus x, 9 minus x, hey, goodbye. 10x over x squared plus 8. And then plus x squared plus 8 here cancels with the factor of x squared plus 8 in the denominator. Then I can bring this 2 to the denominator, and I just get 1 over 2 times 9 minus x. I know, I went through that part kind of quickly. This is just algebra, which you can check me on. And I think that this is as nice a solution as we are going to find ourselves. So let's go ahead and circle this. I'll go ahead and write equals y prime again, just to emphasize that. So this problem, oh my goodness, like I said, very much a doozy. But again, the way that we attacked it was we broke everything down, and we, I just checked it in my math lab, and I got a good job. So thank goodness we didn't mess this up. So what we did, though, is we broke everything down, right? If you take your time and break things down into manageable pieces, then you'll be in great shape. Okay? Be extra careful with all your writing. This is part of why it's so important, and math teachers in the past may have gotten on you about showing your work. If you're not careful and clear with your work, it could be very easy to get lost. So that does it for this video.